Imagine, looking so far into the universe, you're not just seeing distance, you're seeing time, not centuries ago, not even millions, but 13.4 billion years back, almost to the very birth of the universe. Now imagine this. In that ancient light, we find something that shouldn't exist, a cosmic monster. A black hole so massive, so hungry, and so early, it breaks the very rules of physics, and yet, it's real. This is that story. A discovery that shook astronomy in September 2022. The James Webb Space Telescope pointed its golden mirrors toward a patch of sky and captured something extraordinary. There it was, a faint glimmer, billions of light years away. An ancient object, later named JADES-GS-z13. At first glance, it looked like a galaxy, but not just any galaxy, the oldest and most distant galaxy ever observed. Light from this object had been traveling for 13.4 billion years, meaning Webb was capturing it as it appeared just 300 million years after the Big Bang. That's not just old, it's primordial. And then, just a month later, Webb's NIR spec instrument confirmed it with a redshift of Z13.2 officially, making it the furthest spectroscopically confirmed galaxy ever seen by human eyes. Astronomers around the world were stunned. It wasn't just a record breaker, it was a rule breaker, because within this ancient object, something far more extreme was hiding. At its center, scientists found signs of an enormous ravenous force, a supermassive black hole, already formed and actively devouring its host galaxy, and that raised a chilling question. How could something so young already contain something so powerful? You see, according to our models of cosmic evolution, black holes this massive take billions of years to grow. But JADES-GS-z13 shattered that timeline. This black hole wasn't just massive, it was feeding, growing fast, and glowing so brightly it lit up the infant universe. The discovery sent shockwaves through the field of astrophysics. Was this the beginning of a new chapter in our understanding of black holes? Or had we been wrong about the early universe all along? Galaxy, or something else? Just as the astronomy world began celebrating the discovery of the universe's most ancient galaxy, a new question emerged. A big one. What if JADES-GS-z13 isn't even a galaxy at all? In April 2023, a fresh study rocked the scientific community again, proposing that what we thought was the most distant galaxy could actually be something entirely different. Not a galaxy, but a dark star, a hypothetical type of celestial object powered not by nuclear fusion like normal stars, but by dark matter annihilation, a monstrous object, possibly 1 million times the mass of our Sun. Dark stars were once considered theoretical, whispers, ideas born from equations and simulations. But if JADES-GS-z13 truly is a dark star, it would be the first evidence ever of this strange and exotic class of object. And that changes everything. Suddenly, we're not just looking at a question of distance or age. We're questioning the very identity of what we're seeing. Is it a galaxy, assembling stars in the chaotic dawn of time, or a cosmic imposter, a ghost of dark matter, glowing from the inside out? Right now, we don't have a final answer, just clues, just tension, just awe. Scientists are now waiting on deeper observations, more spectra, higher resolution, new data, to pull back the curtain on this ancient mystery. One thing is certain though, whether it's a galaxy, a dark star, or something we've never even imagined, JADES-GS-z13 has already forced us to rethink what we know about the birth of the universe. And the story is only getting stranger. The black hole that breaks the rules. Inside this ancient object, whether galaxy or dark star, lies something even more disturbing. A supermassive black hole, not just lurking quietly at the center, but feeding, actively devouring its surroundings. lighting up the early universe in the process. And here's the cosmic shocker. This black hole exists just 300 million years after the Big Bang. It's already grown to a size millions of times the mass of our Sun, a scale we didn't think was even possible that early in time. According to everything we thought we knew, black holes shouldn't grow this big, this fast. There's a kind of cosmic speed limit, called the Eddington limit. It tells us how fast a black hole can safely consume matter before the radiation it emits pushes that material away, slowing its growth. But this black hole, it's breaking that limit, feeding at 5 times the maximum rate allowed by physics. And not in a short burst, but sustained over time. That's like fueling a fire with so much oxygen it should burn itself out, yet it just keeps growing, brighter, hotter, and hungrier. It's a feeding frenzy on a galactic scale. So how is this even happening? Are our models of black hole formation completely flawed? Or is something else fueling this ancient beast, something we haven't discovered yet? One thing is crystal clear. This isn't just a black hole. It's a cosmic contradiction. A monster that tears holes in our understanding of how the universe was supposed to work. The Eddington limit, and how it's being broken. To understand why these discoveries are so shocking, you first need to know about a cosmic law, one of the most fundamental in all of astrophysics. It's called the Eddington limit, and it's the universe's natural speed limit for black hole growth. Here's how it works. When a black hole pulls in matter, gas, dust, even stars, that material heats up. It glows. It radiates energy, and that radiation pushes outward like a powerful wind, fighting against the pull of gravity. Eventually, an equilibrium is reached, the point where the inward pull of gravity equals the outward push of light. That's the Eddington limit. Cross it, and the force of radiation should blast away incoming material, cutting off the black hole's food supply. It's a self-regulating system. A black hole can only grow so fast, or it shuts itself down. But here's the cosmic curveball. The black hole inside GN-z11, the one glowing like a beacon from just a few 100 million years after the Big Bang. It's smashing that limit, feeding at 5 times the maximum rate, consistently, sustainably, illegally, by the laws of physics as we know them. That shouldn't be possible. This kind of growth should burn itself out in moments, not persist for millions of years. Yet here it is, feeding, growing, defying logic. So how is this black hole breaking the rules? Are we missing something fundamental? Or is the Eddington limit not the universal law we thought it was? One thing is certain, this isn't just a glitch in the model. It's a full-blown challenge to our understanding of the universe. More discoveries, more questions. With each new discovery from the James Webb Space Telescope, one thing has become abundantly clear. The deeper we look, the less we understand. Just when scientists thought they'd found the biggest mystery, a galaxy that's not a galaxy, a black hole that shouldn't exist, a quasar breaking all the rules. Webb revealed something even more bizarre, a swarm of tiny red dots scattered like sparks across the early universe. At first, they seemed insignificant, background noise in the cosmic data. But then astronomers looked closer. Each red dot, a powerhouse, a supermassive black hole hiding inside a galaxy barely out of its cosmic crib. And they're not rare. They're everywhere. If this is real, if what we're seeing is common, then we have a much bigger problem. Because according to our current models, black holes like this should take billions of years to form. But here they are, less than 1 billion years after the Big Bang. Already massive, already feeding, already lighting up the cosmos. Which raises a chilling possibility. What if black holes came first? What if, instead of galaxies forming stars and growing black holes at their centers, it was black holes, born in the chaos of the early universe, that shaped galaxies around them? It's an idea that turns cosmic evolution on its head, a complete reversal of the story we've believed for decades. So now, we're not just asking what we're seeing, We're asking why, and perhaps more importantly, how much of the universe's origin story have we gotten completely wrong? What's fueling this cosmic growth? So how are these young black holes growing so fast, so early in the universe? To answer that, scientists are digging deep into models, into data, and into cosmic history itself. One theory? The early universe was a chaotic buffet of cold, dense, gas-rich galaxies. Galaxies so packed with raw material that black holes didn't just feed, they gorged. Imagine a newborn black hole dropped into a galaxy brimming with hydrogen. The perfect fuel. No competition, no limits. Just an all-you-can-eat cosmic banquet. Another theory is even more radical. These black holes may not have started small at all. Maybe some were born big, not from dying stars, but from direct collapse. Massive clouds of gas collapsing straight into black holes without ever becoming stars first. This could create black holes thousands of times the sun's mass almost instantly. And from there, the growth would be explosive. But even that doesn't fully explain what we're seeing. Some black holes are growing faster than the math allows, regardless of how they started. So maybe the problem isn't just in the black holes, maybe it's in the rules themselves. What if the laws of physics, or at least how we apply them, were different in the early universe? Maybe our understanding of radiation pressure, accretion, or galactic feedback needs a rewrite. Or maybe there's an entirely new force or process we haven't even imagined yet. The truth is, we don't know yet. But one thing's certain. The early universe was far more violent, dynamic, and mysterious than we ever thought. And whatever fueled that explosive growth, it's still out there, waiting to be uncovered. A chemical clue from GN-z11, just when astronomers thought they were chasing a black hole mystery. They discovered something hidden in plain sight. A chemical clue buried in the ancient light of GN-z11, and it might change the entire story. See, light from galaxies isn't just bright, it's informative. It carries a signature, a code made of wavelengths, absorbed and emitted by atoms. By studying this code, scientists can read the chemical makeup of a galaxy, even if it's over 13 billion years old. And when a team at Oxford University analysed the spectrum of GN-z11, they noticed something strange, a nitrogen to oxygen ratio, nearly 4 times higher than anything we see in the modern universe. That's not just weird, it's bizarre. Why? Because in the early universe, heavier elements like nitrogen and oxygen were rare. They're forged inside massive stars and flung across space by supernova explosions. So a galaxy this young, this early, shouldn't have those elements in such abundance. Unless something unusual was happening. And here's where the theory takes a turn. What if this extreme chemistry isn't the fingerprint of a black hole at all? What if GN-z11 isn't being devoured, but is instead in the throes of intense star formation? Maybe it's not a quasar. Maybe it's a hyperactive stellar nursery producing massive stars, fast, then watching them die even faster, in waves of explosive feedback that enrich the galaxy rapidly. This theory doesn't erase the mystery, it just reframes it, because whether it's a ravenous black hole or a newborn galaxy on overdrive, something inside GN-z11 is rewriting the rules of early cosmic evolution. And that's the kind of clue scientists dream of. Rewriting the cosmic playbook science isn't built on certainty. It thrives on questions, on challenges, on rewriting what we thought was truth. And that's exactly what these discoveries are doing. GN-z11, JADES-GS-z13, the swarm of baby quasars lighting up the early cosmos. They're not just fascinating, they're disruptive. For decades, we believed the story of the universe followed a clear arc. First, clouds of gas collapsed into stars. Those stars formed galaxies. And over billions of years, black holes slowly grew at their centers, fed by chance, by collisions, by cosmic time. But now, that script is falling apart. We're seeing galaxies that formed too fast, black holes that are too big, too hungry, too soon, chemistries that don't add up, and light patterns that defy logic. It's like flipping to the first chapter of a book and realizing the plot twist is already underway. Some astronomers think we're witnessing a missing phase of cosmic evolution, a period we never had the tools to see before. Others believe we've fundamentally misunderstood black hole growth, or even the physics of matter itself. Could gravity behave differently under extreme early universe conditions? Could time, energy, or even the laws of thermodynamics have flexed during that chaotic first billion years? It sounds wild, but science lives in the unknown. And now, thanks to Webb, we're confronting mysteries we couldn't even imagine a decade ago. So maybe it's time to set aside the old cosmic playbook. Not throw it out, but revise it, expand it, and prepare for the possibility that the universe has been writing its own story all along. We used to think the early universe was a quiet, dark place, still cooling off, still coming together, still waiting for something to happen, but now we know the universe wasn't waiting. It was already roaring to life. Galaxies were forming faster than expected, stars were exploding in brilliant bursts, and black holes, impossibly large ones, were already feasting in the dark. This isn't just about records being broken, it's about assumptions being shattered. Because if everything we thought about the early cosmos is wrong, then what else don't we know? James Webb has given us a time machine, not just to look back, but to rethink forward, to question the models, rewrite the timelines, and imagine cosmic beginnings far stranger than fiction. We're no longer just observers of the universe, we're translators of its ancient light. We're detectives, sifting through spectral clues and gravitational echoes, chasing answers to questions we're only beginning to ask. And maybe the most humbling realization of all, the universe, even 13.4 billion years ago, was already complex, dynamic, alive with processes we barely understand. So no, this isn't the end of the story. Not even close. It's just the first chapter in a new era of discovery. Because, with every red-shifted photon, every puzzling spectrum, every record-shattering find, the universe is whispering something back to us. You've only scratched the surface. I'm just getting started. If this blew your mind, imagine what's still out there, waiting to be discovered. Galaxies older than time. Black holes that defy physics. Cosmic puzzles no one's solved. Yet. But discoveries like this don't just happen. They happen because we keep asking questions. Because scientists keep watching the skies. And because people like you stay curious. So, if you want to go deeper, to explore the frontiers of space, science, and time itself, subscribe for more mind-expanding journeys. Drop your thoughts in the comments. What do you think GN-z11 really is? A black hole? A cosmic trick? Or something stranger? And if this story left you wondering, that's a good thing. Because wonder is where discovery begins. And the universe? It's just getting started. Thanks for watching. Keep looking up.